A very good afternoon to one and all present. It's my privilege to introduce you to our today's eminent speaker for this session, Dr. Guru Prasad Rao sir. He's a technocrat with over 30 plus years of experience, including product design and development, business development, design research, corporate development, business operations, digital fabrication and strategy. He is currently the director and mentor at Imaginarium India, the most diverse 3D printing company located in Bombay. The current focus is on life and DFAM, besides technology mentoring, building Imaginarium Life, Imaginarium Academy, and technology partnerships across domains. Before Imaginarium, Sir was a professor and chief coordinator PLMCC at JSSATE Bangalore. He's primarily focused on product design, jewelry design, and PLM. He previously served in key roles at Crompton Greaves, Titan, and Tanish. His specialities include 3D printing, its applications in healthcare, DFAM, general management, corporate development, product development, business operations, strategy, product marketing, etc. Now I request Dr. Guru Prasad Rao sir to kindly commence the session as he will be
Thank you.
talking on the topic industrial adoption of AM, the opportunities and the challenges. Over to you, sir.
Thank you very much, Ms. Sadhvi, for this introduction. Again, it's a reintroduction. And I think participants are all these known to us already because they are part of earlier talk also. And thank you again, Professor Kiran Bole, for this opportunity, and the Sardar Patel College of Engineering team. Really compliment for conducting this program and trying to connect with the industry academia with this. And my dear faculty, I think you had a great inputs from various speakers already. Today we are going to examine yet another viewpoint from industry. We are going to really examine some of the projects today and see how and why industry adoption is getting bottleneck in some cases, why there is a slow adoption from industry, what are the opportunities and what are the challenges. That is the topic for the program today. Let me try to share. Let me try to share the screen. Let me know whenever you get it up. Are you able to?
Yes, sir, we are able to see. But again, yeah.
It went off?
No, it is there, but some other screen has come. Two screen. Yeah, now it is perfect.
I don't know why there are two screens.
Yeah, now it's perfect, sir. Now it's perfect.
Perfect.
Yeah.
Okay. Today, without much ado, we'll start the program. So, RP, 3D printing or AM, as we have been knowing about this technology, like any other technology, has a set of opportunities and a set of. We are starting with this slide and we are going to end with this slide. That is the task for the day. Industrial opportunities and challenges in its adoption. And we all know the manufacturing is kind of getting digitized, and in that road to digitization, 3D printing is also one of the active players, which is going to bring the cyber physical systems physical side. And in fact, 3D printing was, as you know, it was licensed to only MIT. And today, everything is getting clubbed under this. And we know it has got various technologies, and we have seen this already. But we should understand that the capability is becoming better and better as the times go by. Of the 30, 35 years of this technology arrival, the early days it was mostly was into using prototypes only. Today, 60% of what we 3D print goes for prototyping application only. Okay, and of course, a lot of them are now also shifted to design validation models. But there are few of special uses wherein it goes as a end user part is increasing day by day. Okay, so this particular time scale, what we are seeing is constantly getting updated, and maybe after 1 year or two, maybe showing a different slide altogether. Some of the technologies like FDM became open source, and open source brought in a lot of accessibility. That means people, when it is open source, technology cost is not there, patenting this thing is not there. You can use your own material, play with it. And this brought innovation also, because the FDM typically, the licensed one or the patented one was Cartesian, XYZ movement. But it gave rise to many others. You know, for example, Delta came, Polar came, Scara came, and only thing is the open source, though it's very good, the reliability could not be achieved or ensured because there was no proper funding, direction, expertise. People who are with the joy of making, the maker community, they started contributing to it, building their own and adopting to their own needs. That's what happened. And today, we find desktop in almost every technology possible, whether it is in FDM or SLS, SLA, or metal. Everywhere, desktop is arriving. You know, and these desktops, in a way, are going to give access to people. But when industry wants to adopt, industry is looking at reliable systems, quality, where consistency has to be there. Otherwise they will not be able to serve their customers. you know and today the technology is trying to offer the development of a range extension. It could be in size of a component built, or it could be opportunity to print more material, dual material, or I can go for a production system wherein not one, there will be many heads which will print a kind of more number of parts. And we also have a few of these technologies are having a reliable build. They're small, but at the same time, we can depend on them. And it is this kind of technologies will actually help adoption by industry. Industry needs reliability. They need a low cost. They need accuracy. But uh, you know they cannot actually afford in the beginning itself a very expensive system. That in that sense, some of these systems what we see are really good. And there is always something which is very low cost. There is always something which is high performing, reliable system which is very expensive. So industry needs, particularly the MSMEs and all, they require something which is in the middle, offering industrial quality products at the same time which are affordable. That is very important. And in fact, the Form Lab, the company which started as a as a startup company, has actually made great changes through improvements. You know, by the way, it started with Form 1, and soon it started working on new systems, Form 1 plus 2, and today we have Form 3 and Form 3B. 3B stands for bio-based things. And they also came out with one bigger system, 3L. And these systems are not only good, reliable, accuracy-wise, they're good, they're affordable. You know. And industry, when they're trying to look at everything with suspicion, they would like to acquire a low-cost system and try it out, toy with it. Once they're convinced, then they will go for a investment, larger investment. So the arrival of these low-cost desktop units are helping adoption. I'm very happy. But the systems, what is being used, has to be a reliable one. It has to be giving the same type of quality, and should be having a good service. That is very important. Value for money, and that's where the whole industry is looking at. And the aviation people, GE, they themselves got interested in it to implement. You want to change, you be the change. That's what Mahatma Gandhi said. So GE, being a leader in aerospace, making a lot of LEAP engines, they adopted this technology so much so that they acquired two companies. One is Concept Laser, the other one is Orcam, and there is no looking back. So they are offering some kind of a research lab to production capability, serial production capability missions. Okay, on powder bed powder bed fusion missions, and Orcam is really industry 4.0 ready. You know, so in future, if the technologies what we have to be compatible to industry 4.0. You know, they're able to do some kind of with a lot of sensors embedded into the system. They are able to give output of these, from the sensors, and these they can be analyzed and can be integrated, and you can have a remote control, remote monitoring, and in situ monitoring. All this is possible because they're embedding this and making it industry 4.0 ready. This becomes another important aspect. When people adapt, you cannot adapt a open source one which is not reliable, which cannot be monitored, and which cannot be controlled. And with COVID, we have industries looking at non-contact control of systems, remote control of systems, so that they don't have to go to a factory to run these missions. They can sit at home and still monitor, still load, still deliver the goods. So all these things are going to really come together in order to make this possible. And that's very important. And in fact, looking at the whole gambit of things, 3D printers come in all shapes and sizes. This is yet another dilemma, to industry. Industry needs somebody to guide them as to what they should go for, what is good for them. It's a kind of a gap I find, and that's where Imaginarium is involved to not only educate academia on one side to get a skilled manpower to the world of additive manufacturing, but also the industry. They need to understand at the top level, at the leadership level, what this can do for me, what is the business case. That's one challenge. Not OEMs, not many OEMs are trying to do, because they're trying to constantly look at selling their machines. While industry wants to understand this technology and the other technology, what is the difference? I should go for this. OEM says, no, no, take mine. Mine is good for you. Okay. So everyone, so industries are able to actually, so we are doing this education to industry also, corporate also, at various levels, top leadership at the R&D level, technology leadership level, And also at the user end, people, we need to go into net and bolts of this technology, training them hands-on and to handhold them when they're doing projects, and also give tryouts, before they can even decide about a technology. If you have two technology, okay, you try this and try that also. Now you decide for yourself through a series of tests. So challenge is OEM themselves are not doing this. That becomes a, because they're not doing it, it is becoming kind of a gap. Industry doesn't know how they can use it. That becomes a very important thing. And bioprinting is something which is also coming. People look at YouTube video and all, they think the technology is ready, you know, and so actually in that direction, that's it. And we all know, we have already gone through this, the reasons why one should consider 3D printing, and we need to understand where it can work for us. 3D printer is good for complexity handling, while it is not so good at handling volume. And so the volume game will continue to be with the conventional manufacturing, while the complexity can be complemented. Complexity cannot be produced by the conventional manufacturing. So that can be offered by 3D printing. But with the 3D printer capability itself is changing, you know, people are able to um, uh, uh, again, this education has to be there, and it's very important to understand and play with the strengths of 3D printing than with the limitations of 3D printing. And today, industry is looking at the limitations of 3D printing because they want to secure their investments, you know, and that's a great challenge, because when you want to secure your investments, you will ask a lot of questions. 3D printing, what happens after 5 years? Because the technological obsolescence is also high. This technology has been looking at the trajectory of growth. The technology is changing almost every 6 months. Okay, something new is coming. So when to buy, it is like a vicious circle. When to buy, when to start. Somewhere you have to start. It maybe is a cost some X, but it will keep on changing. So today, some of the technologies what you bought last year, this year it becomes cheaper and smarter. So you feel like kind of cheated. Why I bought this technology? I should have waited for one more year. But at one more year, one more new technology will come. It is not technology, new technology, but it is about the improvements we are talking about. You know, Today there is a consolidation of technologies. Majorly, they can be classified under the 7 groups as the SME and all have done. But plus minus, they are all having their own particular area of application. Application area for polymer is different. Application area for metal is different. In metal also, there are various types of metal with their own specific areas of benefit, where they can create the value for the products. And so one industry has to study all this. In a study, why it is not widely adopted in industry, it is revealed several perceived barriers to these technologies. So one guy says, no, technology has got a lot of power, but people are thinking there is a perceived barrier, not a real barrier. I say, as a practitioner, there are both perceived barriers as well as real barriers. Okay, and today we have material for the real world is not fully available. Material and processes, understanding properties in different processes like SLA, SLS, LOM, DD, different material, different missions. They work on different principle, and the quality assurance, the cost, the availability, you know, and maybe how to adopt a locally made material into the mission. The mission will not accept it. And what happens to mixing of materials, recyclability, biocompatibility, all this. So industry at large has some kind of an idea, but not a clear idea. And this sector also has no so-called the manufacturing experts of additive manufacturing, are very less, number of people who have a probably a read wisdom, not a practitioner wisdom, because we have for conventional manufacturing about 200 years plus years of manufacturing wisdom. That is not there for additive manufacturing. And for specific sectors like bio or metal additive, aerospace, they also come with their own compliance and standards. We all know 3D printing materials is itself a great area of research in future. More material which are low cost, indigenously made, are going to really help industry to adapt this technology. And if you look at the gambit of material, we can classify them as majorly polymers, metals, and ceramics. And of course, in between, if we mix them, we get the composites also. And this is the large area which is being now well developed with the R&D funds. Industries have belief that if I put money, I will not lose it. That kind of confidence they have, and they are able to go after it. Design is something which is very important, as you know. It starts with design first, and we need to educate not only the industry but also the future skilled manpower. That happens in your institutes, and that's where this FTP program becomes very important key. Looking at the pain points of industry, industry today have a deficit of skilled labor, and many times they take the persons and they train them. So we can, with this input, the industry can expect a kind of industry ready resource. When all the institutes try to impart a relevant information and with skill levels, what industry expects. And we have seen this already, and we have also seen the spectrum of digital manufacturing offering this. I'll not hop on this, but the 3D printing, as we know, is not just one thing. There are so many other things also that has to go. In fact, the idea conversion to a CAD is so much important that you need to have the relevant tools to make it. Yeah, when you talk of relevant tools, you have so many softwares today. Again, it is a highly cluttered space. You have Fusion 360, you have Creo, you have CATIA, you have SolidWorks, you have Solid Edge, you have NX, and so many. I have not put all of them, but they're all necessary to create a 3D content. And there are some areas where you require a different type of content creator, which is called as the digital sculpting ones. For example, Alias or 3D Max or Blender, Rhinoceros, ZBrush, all these and more are also required. And for the maker community and for fun and hobbies, you have free software. That is also required in order to make the 3D content. Without a 3D content, you can print nothing. So it becomes so important. And also take care of how we can expect a defect-free print. A 3D printer doesn't take the CAD directly; it has to be tracked. So for that, we have some of the softwares which not only help in translation but also in other processing, pre-processing of CAD. So they have help in file repair, slicing, support generation, file exchange, file size reduction, and incorporation of textures and more. And industries sometimes feel that how to control this. These files are being exchanged on an email. When it is being exchanged on an email, one may feel that it is lost, because one can share on email, on social media, anything. At the speed of light it goes. So people are also looking at what happens if I buy a cat and somebody mails it, and remails it, and it goes viral, and I lose all the capability. Competitive edge will be lost, like that. So for that, again, the sector is looking at some of the tools by which they can be unique, and they can also take care of the security, file security, and all that. So today, some kind of idea automation is happening with the generative design tools, wherein people are able to get many designs which can be put back, and it will throw many solutions by which one can choose from. You know, like what we see here. You're given the need, it will start giving iterations, and this is going to be the task of designers in future to curate, select, and elect what they need depending upon the specification or the requirements of the product by the customer. And moving forward, design for additive manufacturing is something which is also very important, because customers don't know what to use where. You know, they will start converting all conventional manufacturing into additive, and that is not right actually. That's a wrong way. To do. So it becomes very important to understand uh, where to use and how to use these technology. And that's what has emerged as a new discipline now, called design for additive manufacturing. And the smartness of product is also very important to create value. Otherwise, you will not be able to sell. For example, if somebody can print a small water bottle cap, that is going to cost only, in reality, fraction of a paisa. But if I 3D print it, it will cost you 500 rupees. But why you want to 3D print it? So that is very, very important. Before we embark on deciding to convert one technology today, injection molding to 3D printing, you should ask a question to yourself: why should I do that? That is very important. Why should I change? You know, what value it is creating. And so people are trying to make the product smarter by imbibing, the smartness. That is part consolidation. Do away with all the fasteners, welding, gaskets. You make one part, and geometric freedom by which you can enjoy through additive manufacturing. You can build organic forms, which are hitherto not possible. And biomimicry is a great area which is neglected. You don't have to do anything in nature. People are looking at biometry printers. So it has become a kind of area which is going to help, how to make a smart product of future. Okay. And skill gap is another very important thing. While we talk, this FDP is also trying to look at these skill gaps. It's getting filled, and so that the future manpower is trained in a more, uh, you know, way ready for industry. The lack of appropriate skills, design, production, material testing, very important. Prevent adoption. So there are two types of skills here. People who are already working in manufacturing sectors, they can upgrade their skills and they become senior people. While the novice, the people who are just out, they should also know. So there is a kind of requirement for both the skill levels, that way we can say. And skill level, not only for the CAD people, it is also for the people who actually touch and finish and make these, people who do the quality control of it, people who do the selling of this, all of them have opportunity. So skill level is not only to finishing, we are talking about. And this technology also has a lot of just by printing on a 3D printer. So we may use needle, nose player, then we have scraper knife, exacto that, sandblasting, shot peening, tumbling, CNC, wire cut, EDM, polishing, painting, pigmentation, laser marking, screen printing, pad printing, and more. So there are various things, depending on metal, non-metal. We deploy, all this in order to finish the product. So it is not just enough if we only know about 3D printing and that's the end of it. It is important to finish it so that finally it goes to the end user. They are afraid of it, whether they are going to suffer loss. So the payback time, high amount of technological obsolescence, people are scared whether to invest or not. Industries, businesses want to make profit, not just normal profit, but extraordinary profit. And many times they find it a risky thing to invest into a technology which is becoming obsolete. And so it's a challenging thing to see how people uh, will take it. With the COVID, there was a lot of enhanced support to additive manufacturing because it was one which was working all the time because of some amount of automation. Okay, so the face mask or various other things could be, medical hardware could be easily made and delivered to people. So industry looking at the whole thing with suspicion, unless they get kind of guarantee, they are not going to invest into. You know. So many times I keep saying, you don't look at the investment, you look at the value creation. You can go for 10x or 100x kind of value creation. That is possible. Don't go by the return on investment. You spend 1 lakh, you want 1 lakh. When I'll get this 1 lakh back? That is ROI kind of thing. But why are you looking at 1 lakh? You produce 10 lakhs using only 10,000 rupees. Then that becomes a value creation. And that's where I think it is very important that the challenge is industry to realize this, somehow, and so invest. That's very important. And today, the value chain, what you have, is becoming demand chain, the supply chain and demand chain. Uh, in the conventional wisdom, the marketing, sales, and service. These are the people who create demand. But actually, I'm talking about the end user who is ordering a thing and getting it, you know. And so it becomes a kind of pull system. And customer demands. It is not a manufacturer who has got a solution and he is trying to sell. No. So this game of demand chain has to be understood properly, and you should be able to uh, cater to these needs. And that's where mass customization will come into picture. Anyway, we're not going to go deep into that. So you can see there is a digital switch in SCM from supply chain to demand chain. Very important. The smart world needs complex geometry in small batch quantity, and this is something which is called as agility. Does the conventional manufacturing have this agility? We all know it doesn't have, and that's where it has to collaborate with additive manufacturing and the autonomous robots to deliver things which are highly complex in small batch quantities and still be viable. That's very important. So this smartness is delivered through new design thinking, customization, need for small batch, even one part, optimization, and value delivery. You know, if you can do this, you can actually be more relevant using additive manufacturing. And the real world also needs some of these compliances, standards, regulations, which are very important. Sometimes if you don't have a proper standard, like medical standards, not yet developed fully, and so people are not, they're scared whether I can do it, something happens, somebody will pull me to court, things like that. So it is a highly um, some of these sectors have to have a regulation, and people have to uh, you know uh, conform to standards, so that there is no risk, perceived risk, or the real risk. Real risk is there is a standard available and you're not conforming to it and you're still accepted. That becomes a real risk. But if people are thinking standards are not there, then it becomes a perceived risk. And in fact, you can see the ISO and the STM have come out with quite a comprehensive document today. And they have defined terminology, data formats, the file formats, qualification guidelines, you know, and design guidelines, test methods, and everywhere, including safety. People have some kind of thoughts, but this has to become further enriched, and finally it reaches all of us as a code by which you can actually do it and benefit. So as we talk today, these are some of the standards already done world over, and people are trying it out. They're yet to get a full feedback as to what will work. You know, and depending on material also, a lot of things are getting in falling in place. And if it is done, I think industrial adoption will be zooming. Very important. Coming to the poster boy of additive manufacturing, GE Additives Leap Engine. What we see here is the world's largest and most powerful engine, and they have tried to reduce the parts. They have gone to organic forms, and they have zipped, sufficiently time. So they're also having 300 plus parts to 7. That's a lot of consolidation, I can say, and overall system reliability also increases with this. It is it is called 9x engine, which is the latest one. And then when we have the acceptance criteria standard being established, we also need to have our own internal measurement, inspection, testing criteria, which are as per the standard and available and are important to people who can actually check it. So there is a skill deficit there also. So one has to take care of that. And IP protection, secrecy is something which has been there, a big headache in 3D printing, because digital data can be easily lost. So how to protect the digital data is something which is very important. And in that direction, we have again some of the softwares that will come to our rescue, like Authentize and Leo Lane. They help in file production, protection, and then producing a limited edition object, file tracking, licensing, and also blockchain. So traceability, where, who did it, when they did it, where it is now, is it in the wrong hands? All those things one can actually monitor today, thanks to some of these developments in IT, the cryptography or cryptology, or the forensics. All these are going to be part of this. People have to see how somebody can steal it, you know, and so it's very important. So to understand and build upon that the systems which are going to be more safer. And the whole world is looking at a kind of a cloud factory. A person sitting anywhere in the globe can access internet, and he can order something, and he gets delivered to his doorstep. That is the kind of thing we are talking about. A digital factory is a networked factory which is in low center, which can cater to a diverse population. So many times, applications provide confidence to look at future, and let me take you through some of these which have given confidence to industry, you know, and that's very important. So as I told you, 60-70% of 3D printing is still being used for prototype development only. You know, so these are some prototype made for BHEL, Trichy. Scale models, the small ones are being made. That's where prototypes are used. Sometimes we go for 1:1, a full scale also, wherein one can get a look and feel now the whole structure, even before it is made. Many times it gives you feedback, and that's why they do it. And in FMCG, automotive, the mirror optics, all these are getting printed. And in metal additive, the heat exchange efficacy is something which is driving adoption. Be it conformal cooling like channels in tooling, or a kind of HVAC system where they want to radiate heat. So they're going to have all these, which are really specialized. The value creation here depends on what it delivers. Very important. So once upon a time, jewelry is a piece of gold, a security. I can have a tender, I can submit it and get money, like Muthoot and all. But today, jewelry has become a kind of a wearable, a style, a trend, or an accessory which need not be always gold. So you can see how people are trying to design new things. This is the project we did for Titan, where they needed a flexible, like know, what do you call this as a frame, lace work, something like a lace work. And you can see some of these are having uh, structures which they're having a lot of voids, Voronoi, Voronoi diagrams are mapped surfaces. And these are all only possible to 3D print. They cannot be CNC made because the voids inside. They cannot have a tool to go inside and do it. That's where these become very important, you know, as a technology. So people have been trying to do a lot of customization. This is film trophy. On 59th Filmfare Trophy, we had this type of production. It was a lot lighter compared to the gross ones, earlier ones. And it has a blooming lotus. The whole thing was 3D enabled. So we also went to some fashion show. Actually, continuous talking has its own effect on your trying to deliver. So you can see here how 3D printing has helped us to make things which are complex, assembled, pre-assembled. It can be pigmented. On the right hand side, you have a nylon thing which is actually white in color, but pigmented as red, pink. It can be pigmented any color for that matter. And the complexity is also something which we have been doing. This is a student competition thing, which was actually made by us for a student, Tanya Agarwal. So we make a lot of customized jewelry for many of these companies. So the wedding bangles, they're trying to take the same color as shellac, which are there, which are going on the wedding bangle. Same thing is taken out and matched to have a, enameled rings, which will go very well with that colors. Combination of plastic and gold is tried here. Here using primitive as it is, with a kind of a lattice fill, one can build all those things. What you see on the left hand side. So you can see the nylon build can be sanded, finished, and then you can go for a painting. You will not be able to make out what is there inside, and we have been doing this. You can see the top portion is digitally cut and printed in many parts. This is an IoT device we made. So some of these IoT, which is an emerging field, doesn't require 1 million pieces. And with the electronics miniaturization, the form factor of these products will keep on changing. And that's where companies feel confident uh, to go with these technologies to make some 100, 200 pieces. They don't go for a tooling at all. So this is another system we developed. Again, these are some of the modern products. This is Blue Star's IoT device, and you can see very closely the bottom of this ring. You find some green icons, and these icons actually they kind of show the status what is going on. In medical, of course, we are having different levels. Um Such as level 1 devices, level 2 anatomical models, level 3 you have surgical guides which have to be more accurate and biocompatible. Level 4 we have implants, these materials have to be inert inside the body, and drugs also. People are trying to toy with the idea. If somebody is taking 20, 30 pill a day, it is difficult for them to consume. They miss it, and that is going to reflect in their health. Finally, they pass out. So it's important that we can combine these, of 15, 20 pills as one and given to patient. So patient will have a better way of consuming than having difficulty to take 15, 20 pills. You know, that's where 3D printing will come into picture. And of course, people are also trying to develop print tissue and organs, which is somewhere not fully there. It is going on, but not really there. Very important. This is a braille trainer called Annie, and this is a device. It went to UK. Hundreds of pieces went to UK for testing. BEMPO is a hypothermia monitoring station device. Again, here it was. It came to us for a very special reason. They wanted a skin sensitive, infant skin sensitive material, and we were not having it. We had to actually synthesize a material, see the kind of applied research, and with that, we are able to solve them. Very important. We are so proud. So what you see here is a eye breast exam, is a medical device for scanning the mammary glands and detect early on, if there is a need for operation or amputation, etc. This is a health band. Basically, they wanted to go for a Kickstarter pitch, and they wanted a working of these health bands as per the new algorithm. So we produced all this, and so they were able to actually get the funding. In fact, 3D printing, sometimes we also use it for pets and animals. So we collaborated with some vet doctors and gave a fresh lease of life to this parrot because he had lost a beak. And you can see the beak which is there is actually made by 3D printing. So in Industry 4.0, you can see where exactly 3D printing plays an important with AI and CNC and robotics together with 3D, you're going to have something called as a very strong option to manufacture just about anything. That's what's going to happen in future. Design will lead the consumption, manufacturing will be taken for granted. That means in future, people will not be so much worried about how it is made than consuming it. That has to be maximized. And I think this is the biggest thing what additive manufacturing has done for manufacturing sector. The future is of end user parts, as I told you. It will come in every walks of life, be it uh, uh, cars, be it two-wheelers, be it e-vehicles, be it house, be it drugs, anything. So people are going to keep on printing, and you can see here a kind of new product which can only be 3D printed because of its complexity. It's world's first AI-powered finger ring. This is an example of a compliant mechanism. So let us see the action here. There are no moving parts in this. There are only one part item, and it can take the compressed air and go inside, and it can actually actuate these tongs, and the end actuator, end of a robot can actually help pick and place this component very accurately. And here the input is only pneumatic compressed air. So the reliability of this system is very high because it is not having any moving parts. You know, uh, the variability is less. So people with generative design and all are trying to enhance the market with a customization. It is not exactly fully customized, but to some extent, people have a choice now to buy. So today, if you look at additive manufacturing, uh, the AM future is doable only if industry adopt it in large numbers. So you have uh, you have to have the accessible and reliable technology, acceptable quality, material for the real world, controllable system, and you need to get a predictable results. Consistency is very important, and these are some things which industry is always looking for to adapt. And to sum up, I would like to sum up now with kind of the first questions what we had. The 3D printer or RP or AM, whatever you call it, the opportunity wise, it's very clear. It has agility, it offers complexity, it offers customization, it is offering on demand supply of things, digital inventory. That means I don't have to keep a jewelry in my jewelry company to a showroom to give people. We can show a kind of virtual model, and if they like it, you can order it. So that's called the digital inventory. Mass customization is something which is a world of itself, but we can make it zip the time to market, and local manufacturing. So these are some of the opportunities you have. Looking at the challenges today, the prohibitive cost of technology, of raw material, and all that, software or the maintenance, mission care, what we call, they're all concerns actually for the industrial adoption. You know? And added to this, you have skill gaps also. Skill gap is something which all of you can do. Uh, Again, here we need to work together. Industry and academia should come together to actually address this. So I'm a member of this NASHCOM's skills sector skill group, and we are trying to get as much as the experts on board as possible at NASHCOM, define roles for people, skills, so that the government knows so many different skills are available for this. They may also provide some benefits. Quality is something the industry has to uh, produce the part and take it to the industry and prove it works. This is something which industry is not used to. While ancillaries are there, the tier one, tier two, tier three suppliers are working on it. But when it comes to 3D printing, you know, the quality is something people say, whether it is good quality, full strength, or it has got 80% strength. So that kind of perception is there. So as I can always say, now also I state the same thing. For a real world, it has to have the full strength. At 80%, you cannot use it. You know, you want to use a UTM or a Charpy impact test or hardness test, you have to do it. Same thing. Don't change anything, because quality of the parts which are going into the real use context have to serve the same purpose as earlier, how it was tested and how it is validated. Same thing has to be used. There is no compromise. So people quality and strength are something interlinked. People keep on suspecting whether it is good or not, whether it is going to work for me or not. Need for digital content, that is 3D modeling, is something which has to be. In the earlier days, people had a challenge. People had a lot of legacy data, drawing made on paper, and some are not available because they have, termites have eaten them. So storage becomes a big problem. In future, when we talk of digital content, people can create and collaborate over a long distances just by sharing the files. There are a lot of softwares that are making this collaboration possible. Product lifecycle management kind of software, where it's going to help people to do on a particular part some at one part, and some others, 50% is made at one part, one side of the group, the 50% is done elsewhere. All these are very important. The standards are something which are getting developed. Again, here the final OEMs who want to commission these, their quality will reject simply if you are not making it worthy of selection. So you need to look at the standard, you need to validate, you need to qualify material, you need to submit to those standards, compliance. Those things are important. So in this area, when you are trying to prove it, the testing and certification and qualification and all these become very important, which are something which industry knows today, but they are also bogged down by their own manufacturing setups. So, in a nutshell, uh, while we know about the strengths of the technology, uh, we need to have all this, which have to be overcome. The cost of mission is something which is really making companies to think twice whether I should invest or not. What is the ROI and all that. So, material also. Material is something which a lot of research going on now. I keep saying the hardware becomes smaller in future because it is saturating. The software will become a lot of big thrust area for the sector to help adopt this. And also, the material research is something which is going to be really stretching this technology to its limit. And in both the areas, we have ample opportunity to uh, work on research. You know, very important. I think with this, we come to the end of today's presentation. I would like to give more time for the question and answer, you know, so that I have planned to wind it up early, so that whatever you may have doubts in my earlier talk or today's talk, we can, because many things are learned not by looking at slides, but actually, you know, having a dialogue. That's very important. So with this, I would like to uh, end my presentation and take your questions. Back to you to host. Any doubts?
Hello, sir. Hello, sir. This is Pratyush.
Yes, Kumar Pratish. Yeah.
Yes, yes, sir. Again, the same question that I asked on the first day, that when we are
There are
designing
two people talking. Can we mute them?
okay, just a minute.
Some lady is talking. She is not aware of that. There is a program going on. So if they can mute themselves, yes, Kumar, you can please go ahead.
Okay, yes, the same question that I asked on the first day of the FDP, that when we are designing a new product, so or a prototype through the 3D printing or any other, like I'm very pioneer on the level of 3D printing. Suppose I
Okay.
have designed a model from Tinkercad using Tinkercad. I prepared a STL file, and now when if can I submit it for a copyright, because I'm trying to prevent that from copying for others to copy that same model.
You can see what happens is there is always a intellectual property right. Whenever you have a unique product, you know, you have
Yes.
different levels of IP protection. Though it is not part of today's talk, I can tell you IP protection covers the external looks and looks also. That's called as design registration. But if it has got a technological advantage, you know, and what we call as inventive step, you know, novelty and inventive step, that it should not become too obvious, then you can get a patent also. So these are two intellectual property you have, which you can actually legally get by the Indian Patent Office. It can also be got in various countries, because patent is something which is specific to a country they offer. So if you are protecting in India, it is only protected in India, and if you are protecting in America, it is only protected in America. So if you think your artifact or whatever design you have done is going to, I mean, you can apply for it. There's no problem, Kumar.
Okay, sir. Thank you, sir. And one more query. Actually, we are from pharmaceutical background, sir. But
Mm.
when we are working in the biomedical section, if we are planning to work, so can you just tell me what will be the limitations that will hinder us to just get that those things work out with our profession?
Well, in say pharma, you have the active ingredient and the other things.
Yes,
So
sir.
putting them together, it has to do its function.
Yes.
If your current methods are not adequate, you may want to explore this 3D printing. 3D printing allows you to create layers. You know, so sometimes the drug illusion of drug is periodic. You want to time it every 6 hours or 10 hours. It has to open. Then people keep the active material and they apply another cover, and that inert cover is going to be disintegrating in a particular uh, time. It slowly erodes or corrodes, and it comes out again. The active ingredient is exposed. So people want to have that controlled drug release. Various methodologies are there. People are looking at that as one thing. The other one being for body mass index. You want to have different material, different sized, customized pills made. So where people can actually make any size, any volume pill, for example, one which is 31.5 milligrams or 350 milligram or 150 milligram. Normally, pill has a 500 mg, 100 mg, 250 mg, like that. Standards. At bench you can do one break, sometimes four breaks. But if you want to make more, then it becomes very difficult. So people get little bit overdose or underdose depending on what is available. So people are also thinking, why can't we have a customized pill being made? Again, here it has to create value. Suppose I am going to offer this pill, if the market price is 10 rupees, I have to offer at 10 rupees only. I cannot say, no, no, I have done the 3D printing and it is specific to your body mass index. How much more it can the customer can pay? You may pay 50 paisa more. So if it is 9 rupees, may be willing to pay 9 rupees 50 paisa. But if you take even that small amount, if people are willing to pay, it's a huge market. But you have to still ensure you make it available at that cost, 50 paisa. But how can you customize it to somebody at a very small price? No. And so that becomes a challenge. So, but you can have a kind of mass customization platform which makes it possible. Everything can be, it's a problem, but it has to be solved. It can be solved. It has to be solved, and it can be solved by some means, whether it is 3D printing or by some other way. One has to do. So the dermal patches and all microdermal patches people are thinking of bringing in. People are also thinking of robots, which goes inside the body. You consume it, and it goes to a specific organ, deliver the drug, and then it comes out. So people have been putting a lot of pushing the imaginations where and all it can be used in the pharmaceutical sector. People are thinking of even making, instead of animal tests, can't we print the same tissue and do the drug efficacy test on the tissue? Then go for studies and validate the efficacy of the drug. You know, so people are also looking at that, and some people are looking at even making organs, for example, and how they behave and how long. So people have been trying a bit, but it's all in a way. God is playing hide and seek here. in at least living cells and all, people are doing a lot of work, but still nothing is ready uh, as a end product. You know, that much I can tell you. Yeah.
Okay, sir. Thank you.
Yeah, you have
Thank
to
you.
play, your imagination and push the boundaries. That's what is happening actually, and people are. Some of the companies are working on it. They are going for patenting, but patent is something you have to disclose to people. Patent is given because you are disclosing, but many companies don't want to disclose only. They'll keep it as a trade secret, a trade secret. So that is something. So people might be having all these things. Maybe they are keeping it secret. Not everything is published as a scientific journal. Not everything is patented. Also, people don't want to patent also. So we don't know. Something is working. What is making it work? Beyond just compositions. In the materials, it is not just compositions, it is also the process. If process, the way you can actually patent the way it is made. If it is not made that way, it will not be efficient, or it will not serve the purpose. So a lot of these things, people have an option to go for patent, or they can just keep it as a secret. Yes,
Thank you.
any doubt? No doubt.
Okay, thank you, sir. Thank you for the wonderful talk. I
Most
request
welcome.
participant Pankaj Sela to give vote of thanks.
Yes, sir. Good afternoon, all of you. Myself, Pankaj Shalar. On behalf of SPC organizing team, I extend to really heartily vote of thanks to our respected speaker, Dr. Guru Prasad Rao, sir, who will share his valuable knowledge with us. Uh, Also exploring the 3D printing technology perspective, Industry 4.0, the relation between the fabrication and design, what is the future worlds are need, then uh, also explore the different also introducing the different type of 3D protection software like Leolane, which is one of the software which is protect 3D data protection software. Also uh, essential skill are what type of essential skill are required, sir, enlightening that essential skill like 3D printing software. Fusion 360 is one of the free and open source software. Then after that, sir, exploring the opportunity and challenges, approach like agility, complexity, challenges like the cost of the material, cost of the machine, all of these things. Thank you so much, sir, for give us valuable
Thank you.
guidance.
My pleasure. My pleasure. Thank
So
you.
we are definitely implementing this knowledge in our future research. So this will surely to be going encourage us in our future research. Thank you so much.
Thank you. Thank you so much. Wish you all the best, faculty.
Thank you, sir.